Hello everyone, welcome back to my YouTube channel Feynmath. And from the couple of lectures we are trying to discuss, or we are trying to derive the gradient in spherical polar coordinates. And for the past two lectures we have been trying to do that. So this is lecture number 3. And so if you haven't watched those two lectures, please go and watch them, because the lecture 3 follows from what was discussed in those lectures. So what we have been doing, let me summarize this for you, what we have been doing. So we have expressed my Cartesian unit vectors in terms of in terms of polar unit vectors, and then we used that the matrix, the transfer matrix was actually a orthogonal matrix, and then using the inverse matrix, which was actually Q transpose, we actually got the relations of polar unit vectors in terms of my Cartesian unit vectors, which is shown in the screen, right? Which is shown in the screen, this one. So this was our task 1, and task 2 was actually to figure out my polar derivatives in terms of my Cartesian derivatives, and to invert those relations. So we have reached halfway there, because we have achieved my polar derivatives in terms of Cartesian derivatives. But what I want is actually my Cartesian derivatives in terms of polar derivatives. And why do I want that? Because I have the expression for gradient in Cartesian coordinates, so then I can substitute for these values. I already have those, right? I already have those in terms of polar unit vectors, but I want those in terms of the polar derivatives. So I want to invert this relation, which I have shown in this box. I need to invert these relations, right? Okay, so the idea is to invert this relation. So let's do them. So for that, what I have done is that instead of writing again and again del f by del r and del f by del x and all those things, what I have done, sorry, this will be small f, not capital F. So this would be small f here, small f. So instead of handling every time this del f by del x, del f by del r and all those things, what I have done is that I have redefined my variables. I have redefined my delta f by delta x as small a, delta f by delta y is small b, and similarly small c for delta f by delta z here. I am already making mistakes. Anyway, and today is tedious calculations, so please bear with me. This will be a test of your patience. And similarly, I have redefined my del f by delta r as a, delta f by delta theta as b, capital B, and del f by del phi as my capital C. Okay, so in this variable, the above equations which is in the box reduces to this equation. So what I have is a small capital A, capital B, and capital C in terms of small a, small b, and small c. So what we want is the reverse relation. What we want is small a, small b, small c in terms of capital A, capital B, capital C. Okay, so this is what we want. Okay, so as you look at, so I have named this equation as equation number 1, equation number 2, and equation number 3, and so you can clearly see that equation number 3 doesn't have a c in that, right? So what is my task here? I will use equation number 1 and equation number 2 to actually get rid of this c term. Then I will have an equation in small a and small b, and since my equation third is in small a and small b, then I can use elimination method to actually get my equation only in one variable, either a or either b. So that is my task. So I have done that in my notes. So let me do it for you. So in order to get rid of this small c term in equation number 1 and equation number 2, I multiply my equation number 1 by r sine theta. So this term would become r sine theta cos theta, and I multiply my equation 2 with cos theta, so that this term would become minus r sine theta cos theta, and when we add those terms, this term will go away, right? This is very easy to see. So that's what I am going to do, and I am running out of space, so let me just zoom in for a moment. I think that will be not a great idea for people watching on small screens. Yeah, so please bear with me. So I multiply my equation 1, so this would become AR sine theta is equal to A sine square theta. There is a AR sine square theta cos phi plus B R sine square theta sine phi. I am really sorry for people watching on small screens because I have a lot to write and the space is really small. So I'm really sorry for that. And the C part would be C R sine theta cos theta. So this is my equation number 1. Similarly, my equation number 2 would become B cos theta is equal to AR cos square theta cos phi plus BR cos square theta sin phi minus CR sin theta cos theta, sorry. And when we add those two things, this term and this term will cancel out, right? And we are left with, let me write this in different color. So we are left with AR sin theta plus B cos theta is equal to AR. So when I add those two terms, you can see that AR cos phi is common and we will have sin square theta plus cos square theta, which is equal to 1, right? So this will just give me AR cos phi. And similarly for the other term, you will have BR sin phi common and sin square theta plus cos square theta would give me 1, right? So this is what we have. Let me box this equation and let me call this equation number 4 because we are going to need that equation. Oh, I'm sorry for that. Let me go back and let me draw another box. Hopefully this time it will come straight. Actually my writing is slanting away, so sorry for that. Anyway, so this is fine. So we have equation number 4, and this equation number 4 is in terms of small a and small b. There is no small c there, but we also have another equation which is only in terms of small a and small b. So let me write those equation. So we have capital C is equal to a. Let me write here, capital C is equal to AR sin theta sin phi plus B R sin theta cos phi. So in this video I am going to keep my my video on the side, which appears on the side, to a very small size because these are long expressions and these are going under the video, I think. So I will keep it short, small. Now what I need to do, so I have obtained this equation, and now so let me call this as this is our equation number 3, and now we have this is capital C. So now we have an equation in terms of small a and small b, and we can get rid of any one, right? So let me get rid of a in this equation. In order to get rid of this equation a, what I need to do, I need to multiply this equation number 4 into sin theta sin phi. Then I need to subtract my third equation number 3 multiplied by cos phi, right? because if I multiply my equation 4, this term would be cos phi sin theta sin phi, and this term when I multiply by cos phi, this will be sin theta sin phi cos phi, and if I subtract those two equations, they would cancel it out, right? So let me do that. So I have AR sin theta sin theta sin theta sin theta square sin phi plus B cos theta sin phi sin theta sin phi is equal to AR. So this A term will cancel out, so I'm just cancelling it away, or let me write it AR cos phi sin theta sin phi plus BR sin phi square sin theta, and the C term would give me C multiplied by cos phi is equal to AR sin theta sin phi cos phi plus BR sin theta cos phi square. And now I have to subtract these two equations, right? So when I subtract those two equations, they will cancel out. This term and this term would cancel out, and I would have AR square, and you can clearly see AR square, no sorry, not R square, AR sin square theta sin phi plus B cos theta sin phi. That's why I was saying that you need to be very patient to solve these equations, because it involves a lot of sin thetas and cos thetas, and if you mess up a sign there, the answers won't come out right. And when you go and figure it out, and when you go and trying to figure it out, then where do I have messed up the sign, then you will never find it. So please be patient. Okay, then I have so we have this term, then I have minus cos phi. I think I have messed up a sign already. Let me see. This term has a negative sign. This term has already a negative sign. So I have messed up already. You see? So this term would arise here, minus sign. So then I would have a minus sign there, and instead of subtracting, I need to add those two terms. Right? I need to add those two terms, because then this would and this would cancel it out. So if I add those two terms, I would cancel it out. So fortunately we were able to figure it out that where we have messed up. Okay, sorry for that. And I have to add those terms. So this would give me C, capital C cos phi is equal to BR sin theta. So when you take BR sin theta common from both sides, you have sin square phi plus cos square phi, which is 1. So you have this equation. And from here you can see that we have expressed B in terms of capital A, capital B and capital C. So let me not put those right. So let me express B. My B is equal to 1 over R sin theta AR sin square theta sin phi plus cos theta, B cos theta sin phi plus C cos phi, and this C is capital C. Let me put that into a box, because we have achieved one of the relation. right? We have achieved one of the relation. So that was our goal, because we wanted to express small b in terms of capital A, capital B and capital C, and we have done that. So now what we can do is that we can use this b, and plug it in here. Plug it in either here, equation number 3, or in equation number 2, right? Either you can plug it here, or you can plug it here. Either one of the equations you can plug it, you can plug the value of b, and and then what you will get is small a in terms of capital A, capital B and capital C. So that's what we want to do. So I will plug it in equation number, let's say which one should I choose? Let's say 4. Okay, so let's do that. So we have 4 equation as so let me write the 4 equation. I have AR sine theta plus B cos theta is equal to AR cos phi plus B R sine phi, right? This is our equation, and we will plug it in here. So let's plug this equation here. We have AR sine theta plus BR cos theta is equal to AR cos phi plus BR, and sorry, not B, it is R sine phi divided by multiplied by B. So we have to plug this B here. So this would give me multiplied 1 over R sine theta multiplied by this whole bracket AR sine square theta sine phi plus B cos theta cos phi sine phi plus capital C cos phi. So when we do that, this R and R would cancel out, and this sine theta will multiply with this entire term, and this sine theta would multiply with these 3 terms, right? Okay, so let's do that. So we have AR sine square theta plus BR sine theta, sorry, there is no R, BR sine theta cos theta is equal to AR cos phi sine theta, okay, plus you have A, so let me write it here, plus A sine square theta sine square phi, because this term we have to multiply it by phi, plus B cos theta sine square phi plus C cos phi sine phi, right? So let me take this term to this side. So we have AR sine square theta as common, 1 minus sine square phi plus B, from this term you can take B sine theta cos theta common, and again you have 1 minus sine square phi plus, or rather minus, C cos phi sine phi is equal to AR cos phi sine theta, right? And so 1 minus sine square theta is cos square theta. So we have AR sine square theta cos square phi plus B sine theta cos square phi minus C, this is capital C, cos phi sine phi is equal to AR cos phi sine theta. And you can see that you can cancel one cos theta from both sides, and then you are left with AR sin square theta cos theta plus B sin theta cos phi minus C sin phi is actually equal to AR sin theta. So again, we have expressed our A in terms of capital A, capital B and capital C. So let me write those. My A is actually equal to 1 over R sin theta bracket AR sin square theta cos phi plus B sin theta cos phi minus C sin phi. That is my A. So let me box this equation. Okay. So what number did I give? So let me give this equation as equation number 5. Equation number 5. Let me give this equation as equation number 6. So now what I have done for you, that I have written down, I have expressed my B in terms of this capital A, capital B and capital C using Gauss elimination. And similarly, I have expressed my small a in terms of capital A, capital B and capital C. This is capital C here. Now I will give you homework for you. Homework is to find small c in terms of capital A, capital B and capital C, right? And simply what you have to do is that use equation third, because the third your capital C was expressed in terms of small a and small b, so just plug that small a and small b there and you will find, not equation number 3, because there was no c in equation number 3, small c in equation number 3. Either you can use equation 1 or equation number 2, because in equation number 1 and equation number 2 you have small a, small b and small c. So you plug the values of small a and small b, then you will get a expression of small c in terms of capital A, capital B and capital C. Okay, so you can use any one of those two equations. This is the homework. Please do it, and please be patient with the calculations. It will all work out. So I will write the final expressions for this. This is just the one homework that I gave you. In the final expressions, by replacing my a to del f by del x, and let's keep that. So my final expressions are small a is equal to 1 over r sin theta. So let me copy this because this will take time. So let me copy this relation, copy, paste. This is my first relation. Then I have other one, which is this one, b, copy. Where is copy? Fine. I have b, paste. Oh, what did it do? Let me erase this. Just give me a sec. Sometimes it becomes very unhandy to handle all those things. So this is sin phi. Okay, and I'm giving you the expression for c which you have to calculate, please calculate this. Small c is actually equal to 1 over r cos theta, capital A, let me write capital A here, you have r cos theta minus sin theta b sin theta, and then you have plus 0 into capital C. This is small c. This is our equation. So let me write it here and let me put a box around it. This is my small c. Okay, this is, let's say, equation number 7. Okay, so I think the video is getting long. It's only 26 minutes, so I will pause here and let me give you a summary of what we have did. What we have actually done is nothing, but we are trying to solve our task 2, where task 2 was to write del f by del x, del f by del z, and del f by del y in terms of polar coordinates, in terms of polar derivatives, and we have just renamed them using a, b, and a, small a, capital B, small a, small b, small c, capital A, capital B, capital C, and we have expressed those relations. Then by using Gauss elimination, sorry, I will remove it later. By using Gauss elimination, what we have done is that we have expressed our small a, small b, and small c, which are the partial derivatives with respect to Cartesian coordinates, in terms of partial derivatives with respect to polar coordinates, because then we will able to. So our next task is to substitute the values for ex, ey, ez, and del f by del x, del f by del y, and del f by del z into the Cartesian gradient vector for because when we do that, eventually by manipulating all those crazy expressions, we would finally get expressions which are entirely in terms of polar coordinates. Okay, so that, I think that will be complete in our lecture number or part 4 of this series. So I hope you are enjoying this, and please do the exercises which I left, because this will make sure that you are following the content. And if you have any doubt, or if you have any query, or if you find any mistakes in the derivations, please comment down in the comment section, and also please give your feedback and how are you liking these videos or not, or if you want me to improve on something, or the screen quality, or should I write bigger or something. I am always welcome to all those suggestions. So with that, I will leave you, and I hope to see you in my next video. So thank you.